So let's look at something small in operational research, that's games theory and problems. I mean the problems associated with games theory. Suppose you are given or presented with a problem involving game theory. How can you solve it, and or what's game theory by itself? So we shall learn it from here, or we shall discuss it here. So enjoy. So let's start by understanding the preliminary details under games theory and problems. And here the preliminary details, I'll go through them. Number one, you have the participants in a game who take decisions are called players, and the finite number of all the possible outcomes or actions that are open to a player are called strategies. And number three, when a player selects one of the strategies from among those available to him, then a play is said to occur. Number four, an outcome which is a result of every combination of strategies adopted by players is called a payoff. And then number five, the maximum element from amongst the minimum elements pertaining to each respective row is called a max min. And the minimum element from amongst the maximum elements pertaining to each respective row is called a mini-max. Then when the max min value of a player and the minimax value of his opponent happen to result in an identical element, then the element that element is called a saddle point. If two persons play a game, and when the algebraic sum of the games of both the players at the end of a play is 0, then such a game is called a two-person zero-sum game. It should be noted that the gain of a player is loss of his opponent. Then pure strategy means that a player A adopts minimax strategy and B adopts max-min strategy. Here the game is said to be a pure strategy game when there is a saddle point. Games without a saddle point necessitate the use of mixed strategies, of which we shall look at it in our next class or next video. A player's best strategy will be to maximize his gain or minimize his loss. And when the different games that result from a game are presented in a tabular form, it's called a payoff matrix, as we shall see. Payoff matrix. So let's look at here one of the illustrations that can use when presented with, by a problem. When you are presented by a problem pertaining game theory, here's a problem. Let's start by this illustration before we can tackle our own. Here is a game, as I have been told. It's presented in this form. So this is what we call a payoff matrix. Have player A and player B, have 1 and 2 there. So the question is, find the best strategy for each player and the value of the game. Solution is here, that if a player A adopts 1 and B also adopts strategy 1, then the gain to A will be 2. These 2, I mean B will pay A 2 units. Here, by adopting strategies, A finds the minimum gains and tries to obtain the maximum amongst these minimum gains. By adopting strategies 1 and 2, B finds his maximum losses and tries to obtain the minimum amongst those. So we start by finding the row minimum and the column maximum. So this is the column, these are the columns, and then these are the rows. So let's start by row minimum. This row contains elements 2 and 8. The minimum on this row, the minimum element is 2. Here is 2. Then under this lower row, the minimum element is between 8 and 9 is 8, of course. Let's come here. Column maximum. These are the columns. So the first column, the maximum element between 2 and 8 is 8, and then the maximum element between and in this column 8 and 9 is 9. So how can we find the minimax? We say that the minimax, here is the minimax. We say that the minimax is the minimum element from amongst the maximum elements. So we have found or determined the maximum elements in this. So the minimax will be the minimum element from the maximum. So between 8 and 9, 8 is the minimum, so it becomes the minimax, the minimum from the maximum. Are you getting? Then the raw minimum, the raw min from the raw minimum, we obtain the maximin, the maximum element from the minimum. I have said here, I can confirm and see that the maximin, the maximum element from amongst the minimum element, maximum element from amongst the minimum element pertaining to each respective row is called a maximin. So the maximin is the maximum element from amongst the minimum elements. I have said that these rows, the row minimum, first row is 2, and the second row, the minimum element is 8. So the maximum from the minimum, these are the minimums. So the maximum from the minimum is 8. So 8 becomes the maximin. So minimax is equals to maximin. As you can see, this is the minimax and this is the maximin. 8, 8. So minimax is equals to maximin is equals to 8. The 8 units here represent the element which is called the saddle point, because the minimax is equals to maximin. You can confirm from the preliminaries details where you have said we have talked about the saddle point, when the max mean value of a player and the minimax value of his opponent happen to result in identical element, and the identical element in this case is 8. They are identical. Then that element is called the saddle point. That's why I'm saying that the 8 units here represents the element which is called the saddle point, because the minimax is equal to the maximin, and the value of the game is 8, as it represents the game of the player A. The optimal value of the game is 8. So let's look. This has just been an illustration, so to prepare us for our own example. Now we want to tackle by our own. Are we there? Hope you understand what I'm talking about. So let's look at this example. Solve the following game. Solve the following game. You can see you have player A and player B. These are payoff matrix. As you have seen, you have the elements here and there. Are we there? So let's start by column maximum. These are the columns. So you have the first column, you have 1, 3, 1, 6, 1. The maximum element here is 6. The second column, 2, 7, 5, 7, 4. The maximum element is 7. Third column, 3, 5, 4, 5, 3. The maximum element is 5. Then 4, 4, 3, 8, 5. The maximum element is 8. Then the fifth column, 5, 2, 7, 5, 2. The maximum element is 7. Then let's go to row minimum. Is column maximum, then row minimum. These are the rows. So the first row you have 1, 2, 3, 4, 5. So the minimum element is 1. Second row we have 3, 7, 5, 4, 2. So in this row the minimum element is 2. Then you have 1, 5, 4, 3, 7. The minimum element is 1. We have 6, 7, 5, 8, 5. The minimum element is 5. Then the fifth row we have 1, 4, 3, 5, 2. The minimum element is 1. Are we there? After that, now we find the maximum from the minimum. That's the maximum. So these are the minimums. Are you there? So the maximum from this, the maximum element from this minimum element is 5. So this becomes the maximum. Let's move to the column side. This is the column maximums. So the minimum element from these maximums, we get the maximum. So the minimum element from this 6, 7, 5, 8, 7 is 5. So this is our minimax. The minimum element from the maximums, and then the maximum is the maximum element from the minimums. So you can see that the maximum value of the maximum and the minimax have a value which is identical. The element is identical. We have 5, 5, 5, 5. They are identical. So you can say that 5 is the saddle point wave. So remember, you have said here that when the maximum value of a player and the minimax value of his opponent happen to result in an identical element, then that element is called a saddle point. So we have seen that the maximum is equal to the minimax. So 5 is our saddle point. And now we can say that saddle point is 5. The optimum strategies strategy for A we have 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. Optimum strategy for B, you have 0, 0, 1, 0, 0. Then value of the game V is 5. Value of the game V is 5. Value of the game V is 5. So up to that point we are through with this problem. We have already solved. We started from preliminary details up to this point. Preliminary details, then we moved, we have explained all those. We had an illustration here. Then we have finally solved our own, as you can see, of the value of the game V. So hope you understand. Next time we shall be looking at another game problem, which is we call mixed strategy games. Remember, I have said for this one it's a pure strategy. For what you have solved right now is a pure strategy. Remember, I have said a pure strategy. If a player A adopts minimax strategy and B adopts a maximum strategy, here the game is said to be a pure strategy game when this is a saddle point. But you have games without a saddle point necessitate the use of mixed strategies. A player's best strategy will be to maximize his gain or minimize his loss. So next time, on the next video, God willing, we shall be looking at a mixed strategy game where there's no saddle point, I mean, for example, a game like this, the maximin is maybe the maximin is not equal to minimax. So such a game is what we call a mixed strategy game. So we shall be looking at it in our next video. Thank you so much for watching. Till the next time, bye bye.